Lithium supply has been flagged as a major obstacle to battery electric vehicles, and we have heard numerous reports now from various research firms and lithium miners suggesting that lithium carbonate equivalents are going to be in a structural deficit by 2025. As an example, analysts here from Benchmark Minerals Intelligence gave us this forecast in 2020, courtesy of Standard Lithium's corporate earnings report. And they painted a less rosy picture in 2021, here courtesy of Piedmont's report. Now, according to these reports and others, globally, we should currently still be okay in terms of supply. The deficit is only expected later. But then, why is this happening? This is not the price behavior of a commodity with sufficient supply. This is suggesting something completely different. So what is going on here? Now, the answer to this can only be one of two possibilities, or maybe both. Maybe analysts simply woefully underestimate the size of the lithium-ion battery industry growth. Certainly there is no shame in this. It is notoriously difficult to forecast. Most exponentially growing industries are, and the battery manufacturers themselves are equally cagey with their projections. But the second reason is more obvious, and that is that supply was simply not what it was meant to be. Livent CEO Paul Graves alluded to this in their recent earnings call. It is not only a question of supply, it has to be reliable too. And the reason for the supply shortages could very well be because of an over-reliance on this stuff, spodumene. So stick with me as I elaborate on why spodumene is proving to be such a challenging source. It starts with the rock. Spodumene is a mineral. I'm going to spare you the Wikipedia definition and cut to the chase. It contains this stuff, otherwise known as lithium aluminum inosilicate. The part we are interested in is the first two letters, Li, which stands for lithium. Now, spodumene is remarkably common and has been located in large enough deposits for mining in the DRC, Afghanistan, Australia, Brazil, Madagascar, Pakistan, Quebec in Canada, North Carolina, and California in the United States. And there have been some reports of deposits found big enough for mining in various locations in Europe. Spodumene can be found in igneous rocks called pegmatites. Actually, pegmatites contain several different lithium-bearing rocks, but spodumene has by far the highest yield, so this renders the other rock in pegmatite formations relatively useless. Well, you do get stuff like quartz sometimes, and some miners strike it lucky, like Pilbara Minerals in Australia, for example, who is lucky enough to have tantalite deposits in their pegmatite veins. But it is the spodumene that miners typically get all excited about. Now, because there is so much other crap in pegmatite, it is the yield that gets everyone's attention. So if we look again at the spodumene formula, we want to get from this to a product known as lithium oxide. The rest we throw away. This complex chemistry is what enables us to calculate the lithium yield in spodumene. Once processed, it gets classified typically as spodumene 6 or spodumene 8, which literally means either a 6% lithium oxide or an 8% lithium oxide in the ore. That's right. A ton of spodumene will yield 60 kilograms worth of lithium oxide. Now that is the lithium content inside the spodumene. But what is of equal importance is the quantity of spodumene itself inside the igneous pegmatite rock. Now this piece of information is surprisingly hard to get, but we can work it out. Australian miners tend to report on the amount of lithium oxide in the pegmatite, and this number averages between 1.2 and 1.5%. Basically, they don't bother mining if the number drops below 0.5%. So this basically equates to around 20% spodumene inside the rock. Now I saw Piedmont Lithium also posting around a 20% spodumene yield, and that number seems to be more or less consistent with all the spodumene miners out there. Now, how do we get the spodumene out of the rock? I borrowed this picture here in order to show you. It is quite a complicated process. First, you have to crush the rock. Now, since 80% is basically stuff you don't want, you have to filter it to get to the remaining 20% that's interesting. There are layers of filtration techniques that are applied, so I'm not going to go into detail here. Only to say that after crushing it, washing it, filtering it, and drying it, miners are able to obtain what is known as spodumene concentrate. a fine powder that is around 75 to 80% spodumene. Now, for a lot of miners, this is where they stop. They simply sell this powder. This is what the Piedmont Lithium or the Liontown Lithium deals with Tesla looks like, for instance. So how do we get the lithium out of the spodumene? Well, this step is a bit more complex. The challenge with spodumene is that in its natural state, it is made up of a crystalline structure called alpha spodumene. Alpha spodumene is pretty much impervious to sulfuric acid, so the next step is to change its crystal structure. Lithium manufacturers do this by roasting it, and I mean literally in an oven capable of generating 1050 degrees Celsius heat. This alters the crystalline structure into beta spodumene, which is more amenable to sulfuric acid attack. Now the spodumene gets subjected to a hot sulfuric acid bath, roasted again, and the lithium in it gets extracted in the form of lithium sulfate. Now at this stage, producers can choose to make either lithium hydroxide or lithium carbonate. Normally, spodumene processing plants are associated more with making lithium hydroxide, and my sense is the reason for this is because they are more competitive margin-wise when they go straight to lithium hydroxide, as opposed to the brine miners whose primary product is already lithium carbonate, and who have an extra step to take to get to the lithium hydroxide. They also lose quite a bit of yield in the process, up to 20%, as they convert from one chemistry to another. So what is the actual problem? Well, the problem can be summarized in two words: cost and scale. We are talking high input costs here. It is energy intensive and complex. Processing the spodumene content is one thing, but the supply chain is enormously inefficient. You have to ship tons of a product in which only 6% of it is actually usable. The remaining 94% odd becomes a hazardous waste material that has to be disposed of. This was the stipulated reason why Livent is not proceeding yet with its Nemaska project in Quebec. It just isn't cost effective to ship the spodumene concentrate all the way to China. They are waiting for local demand to pick up in the USA. Which brings us to problem number 2. The industry is moving an enormous amount of crushed rock around and extracting a very tiny yield in the process. We need around 850 tons of lithium carbonate equivalent to make around 1 gigawatt hours worth of battery. The US Department of Energy is forecasting 2.5 terawatt hours of battery manufacturing required by 2030. That is 2.5 million tons of lithium carbonate equivalent. If industry is planning to meet that kind of demand with spodumene, then it will need to be moving and disposing of over 35 million tons of rock each year. The scale of this demand is staggering. So in summary, I don't think the spodumene miners are going to help keep the insatiable demand for lithium in check. I believe that when it comes to lithium carbonate, the brine miners reign supreme, but the spodumene miners are needed to fill the gap. And most likely, since theirs is not a cheap process, we can safely say that there is a cap to the downside for lithium prices. It will simply reach a point where it is no longer profitable to mine. And given the sheer demand for lithium, I don't believe industry will cope with any number of junior miners closing up shop. So there is a vested interest all around to keep the supply chain steady and constant. And as for ending an oversupply, well, you can mine all the spodumene in the world. This will not help. You need the facilities to convert it into lithium hydroxide or lithium carbonate. We will almost certainly see more and more of these come online over time. And it would make sense to position them closer to the source. But they don't get built overnight. And they had better get cracking, because we are clearly already in deficit. Thank you for listening. And if you like this content, please could you subscribe? It goes a long way to supporting the channel, and you will remain alerted to my future video in which I will be focusing on where all the electricity is going to come from for all of this battery electric growth. If you're interested in hearing why Livent is my top pick for investing in lithium mining, then I recommend this video here. And this video is a link to my lithium tracking project, where I try to map my research into production capability of the miners and how this stacks up to the forecasted demand.